Hello, assalamu alaikum. Good night, everyone. And I think all of you are staying well by the grace of Allah, and which is very good to hear that all of you are well. But who are not very well, I'm just praying for them to be well very soon. I think that all of you are looking at my notebook and you are noticing a text which is written on my notebook. Reduction and oxidation causes simultaneously. It is not a sentence. It is a quotation that you will have to prove by your written object. Then I will try my best to prove it chemical with a chemical symbol or systematic way. First of all, if you want to explain it, then you will have to know the definition of redox. What do you mean by redox? Redox means red means red means reduction, and ox means oxidation. I think that you have a nature to know the definition of both two words. What do you mean by reduction? What do you mean by oxidation? First one is oxidation. What do you mean by oxidation? When an element will leave or donate electron, in which process, then the process will be regarded as oxidation reaction. And what do you mean by reduction? When an element will accept an electron or electron, then you can also regard it as reduction. But there are two different words in this text also, which I'll have to explain for better learning. Reductant, and oxidant. Both are a different word in their activities. First one, reductant means the element which will donate electron, then we can call it as reductant. I'm repeating it again. Reductant means which element will just donate electron to others, then you can call it as reductant. So you can obviously say that the other one will be obviously opposite. Yes, oxidant means the element which will receive or accept that electron, then we can obviously say that that element is also called oxidant. Reductant means donator, oxidant means receiver or acceptor. Okay, now we'll have to prove it by chemical equation. Please let me write down it. I'm just writing down a simple chemical formula. Sodium plus chlorine gas, they will produce sodium chloride, which is called also edible salt, and it has the huge uses in our daily life for cooking or for having any edible thing. Now we'll have to balance it, otherwise the equation will not be acceptable. So chlorine has two atoms, then we'll have to make it two atoms. Then sodium had only one atom, but in this situation sodium has two atoms, then we'll have to make two atoms on the other side too. Now this equation is balanced. Now we'll have to identify their ion. We know in a free situation or free position or in independent position, each element has the charge 0. Sodium has the charge 0 in free circumstance. Chlorine has the charge 0 in free situation. But after their attachment or after their bond, then their charge will not be free. They will exchange their electron. For that reason, their charge will be different. So let me write down this. The value, oxidant charge of sodium will be +1. A sodium atom can donate one electron only because it has one surplus electron, and it will evolve it, or it will leave it, or it will donate it to others. And chlorine has a tendency to receive or accept another electron for fulfilling its octet in the last electron configuration. So it will receive. 2 sodium will leave or donate 2 electron, and 2 chlorine will receive those 2 electron, those left 2 electron. Okay, Now let me write down the equation in redox system. First one, we'll have to identify which one is reductant and which one is oxidant. We know here sodium is now donating electron and chlorine is now accepting electron. So sodium to this sodium to that sodium and this chlorine to that chlorine. We know the law. When the positive charge will increase and the negative charge will decrease, then we can identify it as oxidation. Oxidation, obviously it is oxidation. I'm saying it again. When a element will leave or donate electron and it will increase the positive charge or decrease the negative charge, then we can call it as oxidation. At the same way, when an element will just accept or receive electron and it will enhance or increase negative charge and decrease positive charge, then we can call it as reduction. But the element which will leave electron, we can call it as reductant. But the element which will receive the electron, then we can call it as oxidant. But beside this, some element will remain which will not exchange their position or the situation or the charge or ions, then we can call it as spectator ions. So let's start. From the formula that I have said a moment ago, from that source, then we can identify it as it is oxidation. It is oxidation, but sodium is reductant. At the same way, chlorine is oxidation, but chlorine is oxidant. So reductant will cause oxidation and oxidant will cause reduction. Okay, let me write down the oxidation equation. This sodium to that sodium, to sodium was 0 electron, 0 charge. After that, it has donated 1 electron. One sodium has donated 1 electron. At the same way, 2 sodium will donate 2 electron. These 2 electron will be attached. The chlorine was 0, 2 chlorine atom was 0 in charge or electron. But after the donation of sodium, these 2 electrons will be added to chlorine for forming or completing its octet. Then the chlorine will be 2 negative ion. One chlorine has 1 electron more. Then at the same way, 2 chlorine has the 2 electron more. 2 electron we can cut. Then the whole reaction will be 2 sodium not, chlorine gas not, 2 sodium plus ion plus 2 chloride minus ion. This can be regarded as oxidation half reaction and it is reduction half reaction, and it is redox full reaction. So we can say that reduction and oxidation causes simultaneously. It can be caused at the same time. Thank you. I think that you have understood it in a better situation. Thank you.